We're looking at implicit differentiation for basically SS2 students, and for implicit differentiation it helps us to differentiate terms simultaneously, like x and y simultaneously, unlike the traditional differentiation where you have y being differentiated with respect to x. Alright, so most times you have your y at the left hand side being equated to the x terms, but here it is not the case, because in explicit differentiation both the x and the y are differentiated simultaneously. So let's look at how this will go in its most simple form. Okay, so in this concept you differentiate x and you let it be the way it is, but when you differentiate y you add the y dx to it. Alright, so let's see how this goes. So solution. Also here we have x raised to the power 2 plus y squared, which is equal to 16. Okay, so in differentiating x squared, if you are to differentiate x squared, of course you should know using the general formula that this is 2 times by 1 x, so let me just write 2 times by x raised to the power 2 minus 1. Alright, so that is the differentiation for x. So because you are differentiating x, we are not going to add any dy dx. Then plus y will give you 2 times y raised to the power 2 minus 1 open bracket dy all over the x, because we are differentiating y, then is equal to 0. Of course you should know that when a constant is differentiated it gives you 0. So looking at this now, 2 times 1 gives you 2x raised to the power 1, so that lets it be as 2x, and then plus 2y as well, because when you say 2 minus 1 leaves you with 1 power. An open bracket dy all over the x close the bracket is equal to 0. Okay, so further what do we do? Sorry, excuse me. So here we're expected to collect like terms. So the like terms in this concept means terms with dy dx are like terms, and terms without dy dx are also like different terms. So here I'm leaving the terms with dy dx at the left hand side, and I move every other term without dy dx to the right hand side. So here we have 2y in bracket dy all over dx close bracket is equal to, here is 0, then you move plus, because this 2x here has a positive sign, it becomes minus 2x. Alright, so at this point you divide both sides by 2y, leaving your dy dx alone. So dy all over dx is equal to minus 2x divided by 2y. Okay, right now you can leave your answer like this, but seeing that there is a common factor between the two terms, the numerator and the denominator, so you can finally say that your answer is minus 2 cancels 2, x all over y is equal to dy all over the x. This is your answer. Alright, thank you.